Hello everyone, welcome to my YouTube channel. In this video, we are going to learn about arrays and types of arrays. What is an array? An array is a collection of homogeneous elements with unique name, and the elements are arranged one after another in adjacent memory locations. I have taught the definition of an array in my previous video. If you have any doubts, then please go it and watch. I have given the link in the description box. Now let's start to check out the types of arrays. First one-dimensional array. What is an one-dimensional array? The array which is used to represent and store the data in a linear form is called a single or one-dimensional array. In a linear form, which means we can store the data in only one single row or only single column. It can be either in rows or it can be either in columns, but not both rows and columns. This is called as one-dimensional array. Now let's check out the syntax. Syntax is nothing but how we are going to represent this array. First we will write the data type of an array, then we will write the array name and the size in the square brackets. So in this case, how we represent the array? In this integer, first we will write integer, that is data type, and we will write array name A. I have mentioned here the array name, that is A, and I'll write the size 6 because this array has capacity to hold 6 elements in it. So this is how we represent the one-dimensional array. Two-dimensional array. Two-dimensional array is represented by both rows and columns, and this is a rough picture of it for your better understanding. Now let's check out what is this. A two-dimensional array is a collection of elements with two subscripts. Of course, we have two subscripts, one for rows and one for columns. The elements are stored in contiguous memory locations as rows and columns. As I have said you, in two-dimensional array, the elements are stored in both rows and columns. The expression A of I of j accesses an element at the ith row and jth column of the array A. If it is nothing but if I write this expression, then it accesses the element from ith row. The row is represented by I and column is represented by j. If I write this expression, it accesses both I and j. This is what it means. The order of the matrix is m into n, where m is the number of rows and n is the number of columns. Suppose if I want to find the order of this matrix, then I will use this formula m into n, where m is number of rows and n is number of columns. In this case, we have 3 rows and 3 columns. And the last one is the number of elements is m into n. Suppose I want to find how many elements I can able to place in this two-dimensional array. We will use this formula m into n. As you all know, what is m and what is n. M is number of rows while n is number of columns. And I will show you with this example. I have 3 rows and into 3 columns, which is equal to 9 elements. Here we can place 9 elements in this. If you want, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of elements to find, we will use this formula. Now let's move on to algorithms. If you have understood what is one-dimensional array and two-dimensional array, then algorithms is also easy. First we'll study about linear search. Linear search. What is a linear search? Why we'll call it as a linear search? Linear search is nothing but the searching of an element in a linear array, which is also called as one-dimensional array. And one-dimensional array is also called as a linear search. Linear? Yes, because we will represent the elements in either in a single row or a single column, and that is the reason we name it as linear search. So let's start our algorithm. In the step 1, we will set the location is equal to -1. We will set the location is equal to -1. And in the step 2, for p is equal to 0 to n-1, p is nothing but position, n is nothing but number of elements. In this case, we have 5 elements, n is equal to 5 and p is equal to 0. P is nothing but position. From here to here, from a of 0 to a of 4, this is position. And if a of p is equal to le, suppose I wanted to find the element number 7 using the linear search method in this linear array, then it starts incrementing the location where initially my location was placed at -1. So it starts incrementing +1, where +1 it comes to 8 of 0. Again it go, if my search element doesn't matches, then again +1. If it checks whether my search element matches, no, again +1. Whether it matches, no, again +1. Whether it matches, yes. Here comes my search element. So this is my search element. As soon as it matches, it stores the address of the location. Location is equal to p. So location is equal to a of 3. And automatically after this finding the location, it goes to step 3. Before going, we will end the if loop and for loop. And in the step 3, if location is greater than or equal to 0, of course our location should be greater than or equal to 0, because we don't have any element which we have marked with the negative locations, right? My location should be greater than or equal to 0. If it is -1, the array will be empty. The array shows an underflow exception, right? That's why I will state the condition if location is greater than or equal to 0. Then only it prints the location. What is location? Location is equal to p. P is what? P is equal to a of 3. So this a of 3, my search element 7 is present in the a of 3. This is what it means, right? Otherwise it prints search is unsuccessful. Otherwise means what? If my location is not greater than or equal to 0, if my location is equal to -1 or -2 or anything like that, then my search is unsuccessful because the element only doesn't exist. After this, it automatically comes out of the loop after printing my location. This is what I wanted, my print location. I hope you are clear with the linear search. Now we can use another method for searching, that is binary search. We have studied linear search and now we are studying about binary search for finding an element in a linear array. Binary search, step 1. We'll directly go to the step 1. We'll first set base is equal to 0, end is equal to n. N, you know what is n? N is number of elements. We have base is equal to 0 and end is equal to 4. So here I will set base b and end e here, and of course location is equal to -1 as I have taught you in linear search. While see here, while b is lesser than or equal to e, base is lesser than or equal to e, that's what it means, right? So 0 is lesser than or equal to 4. Yes, when the statement satisfies, we will find the middle value of this array. To find the middle value, we will use this formula: integer base plus end divided by 2. What is base? 0, and what is end? 4 divided by 2. We will get the middle value 2. So my m will be here. So this is where my m value, that is middle value, is placed. And suppose if my search element matches with the middle element, then this statement will satisfy. If le is equal to a of m, if suppose my search element is 7, I wanted to search this 7, and this element matches with a of m. A of m, what is a of m? That is a of 2. Then location is equal to m. Then automatically the location stores the address of m. What is the address of m? 2, that is a of 2. and if it satisfies, automatically it comes out of the loop. Go to the step 4. What is step 4? Step 4 is exit. And if my search element doesn't matches, if I have my search element in 6 or whether my search element is 8, how to find it? We will go to this step, that is whether first it asks, first we should have to ask that if element is less than a of m. If my search element is less than a of m, that is if my search element is less than this middle number, if it is like whether it checks if it is less than this middle element, then it searches only in this part and it sets end value is equal to m minus 1. What is m minus 1? 2 minus 1 is what? 1. So my end value from here to it jumps here. My end value will be here and all this part will be vanished off because we have no use with this. Once the end value is here, it starts to searching my element only in this area, a of 0 to a of 1. Why not a m? Because we have already searched this whether my element matches with the middle value. That's why not m, only m minus 1 we will use. And suppose if my search element is greater than a of m, then we will set base is equal to m plus 1. My end will be here only, but base we will bring it here. My base I will bring it here. M plus 1 is what? 2 plus 1 is 3. So base will come here. Base will be here and end will be here. In this area only we will search and the upper part will be vanished off because we have no use with it. And after finding it, we will end the while loop. Here we have used a while loop, right? We will end it, and in the step 3, same as the linear search, if location is greater than or equal to 0. If my location is greater than or equal to 0, then only it prints the location, else print search is unsuccessful. So only this is the main body we have to understand. This is all are common. First we have to set base is equal to 0, end is equal to number of elements, that is 4, then location is minus 1. And first we have to find the middle value. Whether my middle value matches with the a of m, then location is equal to m. Otherwise, if my if my search element is lesser than middle value, then end is equal to middle minus 1. Otherwise, base is equal to middle plus 1. Only this much. I hope you now understood. Now, inserting an element. Now we have learnt about linear search. Now we have learnt about binary search. Now let's go to inserting an element, insertion of an element in an array. Without wasting much time, I will finish this fast because it's very easy. Linear search is also very easy, binary search is also very easy, and inserting an element is also very easy. Now directly we'll go to the step number 1. J is equal to n. J is equal to n. We will use the pointer j. J is equal to n. N is what? As you all know, n is number of elements. We have 4 elements, so of course j is equal to 4. And repeat steps 2 and 3 while j is greater than or equal to k. So first let me make you understand what is k and what is item. K is the position where we wanted to insert that element, and the item is the element which we wanted to insert in the position number 3. Here I want to insert 10 in the position number 3, where here I wanted to insert this 10. It means that's it. And if j is greater than or equal to k, whether j is greater than or equal to k, what is j? 4, and k, what is k? 3. Whether this is greater than or equal to k, if s, then a of j plus 1 is equal to a of j. A of j, what is a of j? A of j is 4, right? And a of j plus 1 is a of 5. A of j plus 1, a of 5. Here a of 5 will come, and the a of j, what is a of j? A of j is 9. The address of a of j is 9. The 9 comes here, and this position gets emptied. And again it checks this condition, whether 3 is greater than or equal to 3. Again a of j plus 1 is equal to a of j. Again 7 comes here and 8 comes here and 8 becomes empty here. This space gets emptied. Again it checks the statement to whether 2 is greater than or equal to 3. No, it doesn't comes. This condition fails. It comes out of the loop. Then step 3 is j is equal to j minus 1. Now my j pointer will come here. J minus 1, 4 minus 1, 3, right? And it comes out of the loop as I've said. Next, step 4, a of k is equal to item. A of k, what is a of k? K is 3 and item is equal to 10. In the third position, my item goes there. In the third position, I'll place my item. And n is equal to n plus 1. We are incrementing the n plus 1. Incrementing means we are adding 1, we are adding the n. Why we are adding? We have inserted an element, one element. If we have inserted one element, of course the number of elements n, that will be plus 1. If we have inserted 2 elements, then n plus 2, like that. Very simple. After incrementing, we will exit from the algorithm. This is just an algorithm. While explaining you about program, all doubts will be cleared. If you are understood, then it's well and good. If not, while I will make a programming video, in that you will understand. So this is how my array looks like after inserting an element. In the position 3, you can check here, in the position 3 I have inserted this 10. Before inserting, my array was like this, and after inserting, my array is like this. I hope you all understood. Now deleting an element, even this is also very easy. This is just ulta of an inserting of an element. First we'll set item is equal to a of p. What is an item? Item is the element to be deleted. I want to delete this 10. A of p is position. As you all know, position is 3. In this position, the element 10 I wanted to delete. For I is equal to p to n minus 1. For I is equal to p, we will set the pointer I here. I is equal to p. P is what? 3. So my I pointer will be here. A of I is equal to a of I plus 1. A of I is a of 3. A of 3. Then a of I plus 1. A of I plus 1. What is a of I plus 1? 3 plus 1 is 4. So this element goes here. First I will take this 10 with the help of pointer I. This 10 is stored by pointer I. First I will take this, copy this 10 in this pointer. If I copy, this space will be emptied, right? After that I will shift this 8 here. Again this will be emptied. I will again shift this here. That's it. This is the concept of deleting an array. The 10 element which I wanted to delete is copied by this pointer, and I will go on shifting the below element to the upper element, below element to the upper element. Like this it continues until the condition satisfies. That I will explain you while doing the program. Now don't worry about it. After that, n is equal to n minus 1, because we have removed one element. Of course, one number of elements, that is number of elements, should be minus 1. If you have removed 2 elements, n will be minus 2. If you have removed 3 elements, it will be minus 3. Simple. Then step 4, exit. If you wanted to see how it looks like something like this. After deleting an element, see, in the step 3 I have deleted 10. Where you can you see here 10? No, right? So this is how my array looks like after deleting an element. I hope all the points are clear. Even if it is not clear, then please do watch the video once again. Even if it is not clear, then don't worry, I will make another video with the programs of inserting element, deleting element, and linear search, and also binary search. So if you liked my video, then please do subscribe to my channel and like, and please share and comment it. Thank you.